Okay, so at the start of this chapter, we'll be talking about quadratic functions, and we'll be talking about it in a couple different forms. But let's dissect the quadratic function graph, which would be a parabola. Hopefully you recall the parent function of a quadratic is f of x is equal to x squared, and we can see that the vertex, okay, which is like the in this case the bottom of the U shape of the parabola, is located at 0, 0 on the parent function parabola. There's also another line known as the axis of symmetry. And what the axis of symmetry is it's an invisible line that cuts the parabola vertically in half, so that the left side is symmetrical to the right side. And we'll be using that. So we can expand on the quadratic function as far as, the standard form, and it can be written as a equals, or g of x equals ax squared plus bx plus c, which is one you're probably familiar of seeing in Algebra 1. And we saw another form when we first talked about parent functions. So we'll be looking at the both of these forms and another form as well. We want to make sure though that our b value is equal to 0, and in that case the vertex lies on the y-axis. So let's take an example here. Here I have y equals negative 1/2 x plus 4. Now, from our previous discussions of quadratic equations, we can tell that we can tell a few things from this equation here, just in the way it looks. Like, for example, it's shifted up 4 with the plus 4. And it's going to be reflected, meaning it's going to be opening down, and the 1/2 tells it's going to be a vertical compression or vertical shrink, so it'll be wider than the parent function. But what we want to do is accurately graph this, and I'm going to show you one method in which you can graph this. And what I need is I need at least 5 points. So like on a test or quiz, when you're asked to graph, you need to give at least 5 points, and we can just pick some arbitrary x values with this method. So we're just going to pick x values. Negative 2 to 2 will be fine. We can tell it's not horizontally shifted because we don't have any h value, and there's no h value in this form anyway. So the way we'd go about this is just we would substitute. Let's say we'll start with negative 2. So I want to find what is y when we have negative 1/2 times negative 2 squared plus 4. So y is equal to negative 1/2, and then that's going to be times 4 plus 4. Scrolling down, I can continue this. Y is equal to, and then this is going to give me negative 2 plus 4, and thus y is equal to 2. So I'd go back and I would fill that value out in my table, and we said that was going to be 2. Okay, and then we would repeat that process. We would, we would substitute in -1 and 0 and 1 and 2. I'm going to go ahead and just fill out those values. Now you would want to work these out and show your work if if you're doing an assessment. So let's go ahead and fill that out. So when x is -1, y is 3.5. When x is 0, we can surmise that's going to be 4 because that's where the vertex is going to be, as we can see with the +4 at the end. +1 will give us a y value of 3.5, and then 2 will give us 2. So let's plot those points. So -2, +2, -1, and then positive 3.5. So 1, 2, 3, and halfway between 3 and 4. 0 and 4. And then it's going to be symmetric. So I really don't even have to look at my values for this one. Okay, so now that I have those, I can go ahead and draw my parabola. It's going to be a bit challenging for me on this. Make sure you extend your parabola the length of the graph, and of course don't forget your arrows. Okay, so that's one way in which you can graph a parabola. Just substitute in x values, find the corresponding y's, plot those points, and draw your parabola. So basically, there are several properties based off the parabola and based off the quadratic equation in standard form. Remember, this is this ax² plus bx plus c is standard form. And so, like for instance, here I have a parabola that's opening up because the a value is greater than 0. But I want to also point out that you have an axis of symmetry, and that always goes through the vertex. The axis of symmetry always goes to the vertex, and that's why it bisects it into two parts. But the axis of symmetry can be found by this equation of x equals -b plus 2a, where b is the coefficient in front of x and a is the coefficient in front of x squared. That's going to come in handy. Additionally, the y-intercept in standard form is always going to be 0c, where c is your constant at the end. Likewise, I mean, I can see it here. Again, the axis of symmetry is x equals -b over 2a, and my c value is going to be, or my y-intercept is going to be 0c. That corresponds with the constant in this equation. And this opens down because our a value is less than 0. aka it's less than 0. It's a negative number. Now, if it opens up, the vertex is regarded, the vertex would be here and is regarded as a minimum. Okay, and this is when a is positive. If it opens down, our vertex is regarded to as a maximum, and this is the case when a is negative. So you'll be asked to identify from an equation if what type of vertex is it? Is it a minimum or is it a maximum? Okay, so let's graph an equation in standard form, but let's take a different approach. Instead of just plugging in, a whole bunch of points, let's take a slightly different approach. So the first thing I want to do if I want graphing something in standard form, is we want to, the first thing I want to do is I want to, get the axis of symmetry. Axis of symmetry. So recall that's x equals negative b over 2a. Notice it's x equals because the axis of symmetry is a vertical line, and vertical lines are graphed when you have x equals a constant, x equals a number. So let's get that axis of symmetry. So x equals, now our b value is going to be 6, so here's negative 6 over 2 times a. Our a value, since it's a negative in front of the x squared, is going to be negative 1. So we would evaluate that as being negative 6 over negative 2. Therefore, x is equal to 3. Okay? And that's going to be our axis of symmetry. I'm going to go ahead and draw that in. We draw the axis of symmetry with a dashed line because it's not actually part of the visible graph. It's just a guide. I mean, it's something that exists, and we use that as a guide to help us graph our quadratic. Okay, so now the second part is we're going to find the vertex. And it's easy to find the vertex because it lies on the axis of symmetry. It's somewhere on this vertical line. We just have to figure out where exactly. So here's where we substitute our x value in order to find our vertex, to find our y for our vertex. So it's y equals, and then negative 3 squared plus 6 times 3 minus 8. Now I want you to keep in mind I'm substituting in a 3. Okay, the negative is applied to the 3 after you square it. Okay, because assume that's a negative 1. Remember, you do exponents before you do multiplication. So when I evaluate this, this is going to be 3 squared, which is 9, and the negative makes it negative 9. Okay, plus 18 minus 8. Now we're going to work that out. So that's going to be 9. Negative 9 plus 8 is 9. Minus 8 is going to give us 1. So my vertex is located at 3, 1. Okay, and I'm going to underline that. So 3, 1. There's my vertex.